Yeah, so we're looking at this problem here, which is talking about a geyser. Okay, the geyser is happening here. It's talking about the temperature T. Okay, so that's the temperature there is on the y-axis. Okay, capital T can be modeled by the function where small t, so that's what's going to go on the x-axis, is going to be minutes from midnight. Okay, so that's what's going to go into Desmos. Of course, that's going to be y and that's going to be x, but when we're writing it down, we have to talk about it like that. So we've got the function for one geyser already. So let's just really quickly, just to get ourselves a good idea before we chuck it into Desmos, give it a little bit of a sketch. Okay, so just looking at this one here, 55, that's our plus C, or the vertical translation, which is normally written here, but that's fine. So that means the middle, I'm just going to go here. Remember, these drawings don't have to really be that accurate. The amplitude is 45, so that means the maximum is going to be the middle plus 45, so it's going to go 45 up. So that's 100, and the minimum is going to be 55. We're going to minus 45, so that same distance, so we'll make it look like there, which is about 10. Okay, it's a sine graph, so a sine graph starts, let's make it blue, starts in the middle, right? Then it goes up to the top, into the middle, down to the bottom, into the middle again. Note that that's going to be one period, and that's half a period, that's a quarter of a period, that's 3/4. So it's always thinking about how it divides into quarters there. Okay, and then the only thing we've got left to figure out is the period. So we can see there the frequency is pi over 15, and the period is always 2 pi divided by the frequency. So the period is therefore 2 pi divided by pi over 15, which is the same as 2 pi times 15 over pi. Cancel those out, so the period is 2 times 15. So the period is 30, which shows us there that half the period is 17.5, and a quarter is half the period, 30 is 15, and the quarter is 7.5, and whatever those things are. Okay, we're not super worried about that. We're just doing this to get us a pretty good idea about what's happening. There's the temperature, and the time is in minutes, and this is in degrees Celsius. So what we're looking at is how the temperature fluctuates and the geyser goes up and down like that, right? And now, of course, when I go into Desmos, I should know what it looks like. Okay, so if I type it in, I'm going to go 45 sine, and note that I'm using x instead, but I get pi over 15. Got to push forwards there, so because if the x is still the denominator, that's no good. Okay, and then I'm going to put plus 55 on that side. You'll note that I can't see it, so I'm doing this for the benefit of people who haven't really done it that much. There it is there. But going back to here, we know it should be going from 10 to about 100, and the period is 30. So that's why I'm going to go over here to the preferences here, and I'm back my x, go from about 0 to 30. That's going to show me one period there, and I'm going to make my y-axis, which is the range, go from 0 to, it was going up to about, where was it again? It was going up to about 100, so I'll make it go from 0 to 100. Okay, if you're finding all this stuff relatively simple, just skip forward to the other stuff. But so there we go. So now if we look at x equals 30, you can put that in. That's showing me there's a period. Fantastic. And then we could put in the middle bit just to make sure. Yep, that's definitely right. And there's my maximum was 100, and there's my minimum was 10. So that's just helping me to realize that I've definitely definitely got my thinking correct. So that's fantastic. I've got that in there. Just going to pop that away. Right. Now, one thing we didn't really talk about is what time is measured in. Now, oops, that's not what we wanted. I'm going to highlight it. Now, time is the amount of minutes from midnight. Okay, so time equals 0 is midnight. Okay, so that's important for now when we're getting to the hard part, I guess, harder part, which is actually now we have to actually figure out the equation for the other geyser. Okay, so thinking about that, we have another geyser nearby, temperature fluctuations in the same way, except that its maximum temperature is 85 and its mean temperature, so that's the middle, isn't it, is 45, right? Okay, so we'll start off by sort of drawing that up. We'll do the same thing we did before. So we're just doing this on a separate one because when you start putting them together, it gets confusing. So the maximum is 85, right? And the mean, so that's the middle, is 45. So obviously that means the amplitude is just 95 minus 45, which is 40. That's nice and simple. And so therefore now we can easily find the minimum, right? It's just the middle there, 45 minus 40. So it's 5 degrees. So it's just down there. So slightly different than the last one, isn't it? This is where this is different here. It's at its mean temperature 3 minutes before midnight. So remember, time is equal to 0 here. This is midnight, isn't it? So that's midnight. Don't know why that's so thick. Anyway, so if that's midnight, then let's just make that a bit smaller. Then 3 minutes before midnight is maybe like there. Okay, so if we want to think about this model here is actually starting off at 3 minutes before midnight. It's starting off here, isn't it? Okay, so it's starting off 3 minutes before midnight, then it's going up and down and up again. So it's starting here. Okay, so what we want to maybe think about it in another way is think about, well, this is very close to a sine, just a regular sine. Doing dotted lines wasn't really the best idea. Anyway, it's just a regular sine graph, and we can see it's been moved. Everything's been moved from here to here. So it's just been moved back 3, hasn't it? It's just been moved back 3. It's gone back here to, now that's minus 3, isn't it? Okay, so first of all, let's just think about it if it was a sine model. Okay, we know everything. We know the maximum, we know the minimum, we know the middle. What we don't know is the period. Now let's think about this. If it is at its mean temperature 3 minutes to midnight, so that's minus 3, and then it's at its mean temperature again 20, so it's back here, it's at its mean temperature again. This is going to be 27 minutes after midnight. So what's that length of time? That's going to be, it's 3 minutes there to get to 0, and then another 27, so that's 30 minutes. And we know from here to here is half the period. So if from here to here is 30, then that from here to here is another 30. So therefore the period is 2 times 30, which is 60. You don't even need to write that down. Remember, everything I'm writing down is what you should be writing on your paper. All of these things is evidence that you know what you're doing. So therefore, if the period is 60, then the frequency again is 2 pi divided by the period. I'm not going to write down that formula again, but 2 pi over 60, it's pretty easy, or pi over 30. One thing you might recognize is it's always just pi over half the period, isn't it? So that's B. Okay, so now we have our formula, really, don't we? Temperature equals the amplitude sine, and it is pi over 30. So this is just pretending, looking at the red one, the non-translated one at the moment. times t, and the middle or the vertical shift is, oh, I just had a notification come in there. Oh, that's annoying. That's fine. 45. Okay, just double checking that. Yep, that's all good. Now, the horizontal shift on this one's really easy. We don't actually have to calculate anything because all we're doing is we're thinking about this particular one we've got here is just shifted everything. Everything has moved across that way. Everything's moved -3, hasn't it? It's moved across 3. So if it's moved across -3, I'm just going to give myself a little bit more room. I don't even have to rewrite this. I'm just going to redraw it. Okay, I'm going to put a brackets there. We're going to put t. If it's moved across in the negative direction, then we're going to have +3 there, plus 45. And there is my equation there. So now we can go chuck it into Desmos and see what it looks like. Right, now just like before, we might want to just put in our maximum minimums according to our little diagram we made. Where is our little diagram? There's our diagram. The top was 85, the bottom was 5. So let's give it a go. So y equals 85, y equals 5, and the middle is 45, y equals 45. So this is just really helping us to make sure we're doing everything right. So then now we're going to have to type in y instead of capital T, but that's all good. 40 sine brackets, and then we got pi over x instead of t. Now remember we got to push, oh, what am I doing? Not pi over x, pi over 30. See, there we go. And don't forget, if you put an x now, it's going to be way off the x. You got to push across, put x there. We need to put a brackets actually there because we've got the horizontal shift. Close brackets. Note C, we've got a couple of brackets there, just like how I wrote it down. And then plus 45. That's getting us in the right spot. Okay. And we can see there, is that right? Yes, it's at its mean temperature 3 minutes before midnight. So 3 minutes later at midnight, it's just about there. And what is the period again? It's 60, right? So if this is there, it should be going 30 minutes later, it's at 27, and another 30 minutes later, it is here, so that's 57. So we have that all good. That's fantastic. Okay, and I just realized I'm going to run out of time, so I'm going to do a part 2, which is actually quite good. So the first part is just us figuring out the models, and now the next part is us actually figuring out what we need to calculate with the models.